Hello everyone, it's me, Miss Pollard, and we're back with another math YouTube video. So today we are going to be going over graphing two variable inequalities on a coordinate plane. So there, as always, are steps to complete to solve these problems. So let's take a look at those steps. So the first step is to graph the line as if there is an equal sign. Let's just act as if it's y equals a equation. So we're going to graph it like that, but then we need to think about that inequality symbol. So if it's a less than or greater than sign, we are going to put a dashed line. If it's less than or equal to or greater than or equal to, we're going to do a solid line. And this makes sense because we are or equal to or less than or equal to, including those points. So because it's a solid line, we're including those. Where a dashed line means we're not including it. Those points are not going to be included. Once we graph these, we are going to pick a point on one side of the line versus the other. I like to say above or below, but sometimes it's left or right. And then whichever point when we plug it into our inequality works, we're going to shade that side. So let's take a look at a problem to see really what I'm talking about here. So if I take a look, I'm going to solve this as if it's y equals negative 7/2 x plus 2. And we go up to, well, 1, 2, 3, 4, 5, 6, 7, 1, 2. Once again, I like to do this just so I remember what direction I'm going when I go down. 1, 2, 3, 4, 5, 6, 7, 1, 2. Because it is a less than sign, I'm going to do a dashed line. We really want to make it look like a dashed line here. I like to pick points now. We're going to be picking points on one side of the line versus the other. So this is, for this instance, it's the left side versus the right side. I'm going to pick 2 points. I like to pick these points based off of what I think is easiest. I like to include a 0 in them, just so we are plugging in a 0. That's not as difficult. So I like to choose the origin unless it's crossing the origin. You can't pick that. And then I'm going to pick 2, 0 because we have a fraction with the 2 in the denominator that will help cancel it out. So we're going to plug in 0, 0 over here. We're going to plug in 2, 0 over here. So when I plug it in, my y is 0 less than negative 7/2 times my x of 2 gives me negative 7 plus 2. And that's negative 5. Is 0 less than negative 5? No. So this side is not going to work. Let's see about 0, 0. When I plug in 0, 0, I get 0 is less than negative 7/2 times 0 is 0 plus 2. Is 0 less than 2? Yes. So that side works. Some of us like to plug one point in, and then if we're wrong or it doesn't work, we choose the other side and just shade it. We don't test 2 points. I don't like to do that personally because what if I did my math wrong and I said that was wrong and this one was wrong too? Clearly I did something wrong. Wrong, wrong, wrong. So we are going to test both points just to make sure everything checks out. So because 0, 0 works, I'm going to shade on the side that 0, 0 is on. Of course, I'm not going to use my marker because it will drain, but I have an example here. And I can erase this so you can have a better look. So we are shading on this side. This means that all points on this side are solutions to this inequality. Let's try another problem just in case we weren't clear with this. Now we have a problem in standard form, and to be able to graph it, we need to put it into slope-intercept form. So to do that, we subtract 2x from both sides, and we get negative 5y is greater than or equal to negative 2x plus 15. Divide by negative 5. When I divide by negative 5, we have to remember our inequality rules. When we divide by a negative, we're flipping the sign. So we get y is less than or equal to 2/5 x minus 3. If we didn't flip the sign, our inequality is going to be wrong. We're plugging in the points, and we're going to shade the wrong side. So I'm going to go down to negative 3. Go up 1, 2 over 5. Down 1, 2 over 5. Because it's an or equal to, I put a solid line through it. And I like to say this is a solid problem. Once I do that, again, I'm going to pick my 2 points. I like to choose 0, 0, just out of comfort. And then I'm going to pick one below it, which is 0, negative 5. You could pick any 2 points above and below the line, any 2 that call out to you. These are just the ones I picked because when I plug in negative 5, this will cancel out the fraction. There'll be no more fraction anymore. So let's plug in 0, 0. I'm going to do it the original because what if I did a little math error and that would mess it up? We have 2 times 0, which is 0, minus 5 times 0, which is 0, is greater than or equal to 15. Is 0 greater than or equal to 15? No. So that side doesn't work. Now let's try our 0, negative 5. We have 0, negative 5. We are going to plug in 0 for x. So 2 times 0 is 0. Negative 5 times negative 5 gives me plus 25, which is greater than or equal to 15. Is 25 greater than or equal to 15? Yes, so that side is going to work for us. So I would shade this part down here. I love when I give a quiz or test on this. I'm always hearing the shading like we're in an art class. We're bringing art into the math classroom. So I'm going to show you what this looks like. It would look something like this. Let me just erase so you can see. Once again, the points down here are the ones that are included. These are the solutions to the problem, where likewise, these would not be the solutions to the problem. None of these points will work. Let's try some problems where we just have a single variable and see what we would have to do there. So we're going to solve this problem as if we would algebraically, where we're going to have an x term on one side, but a constant on the other. So I'm going to distribute. I get 6x plus 15 is less than 5x plus 16. Subtract 5x, I get x plus 15 is less than 16. Subtract 15, I get x is less than 1. We are going to do the same steps where I'm going to graph it as if it's x equals 1. And we have to recall from pre-algebra, this is why it was so important when we're graphing in pre-algebra, that x equals 1 is a vertical line, up and down line. So we go at x equals 1. Because it's just a less than sign, we put our dashed line. Now, instead of plugging in points, I'm going to use my mathematical reasoning. You can plug in points to see what works, but you'd only be working with the x values. I like to mathematically think. We're thinking about x is less than 1. Well, which side of the graph is x less than 1? On the right or the left? Well, these x values are getting bigger. These are smaller. So x is less than 1 is going to be on this whole side. So when I shade it in, this is what I get. We have x equals 1 here. It's a dash because it's less than, and I'm going to shade all the ones on our left side. This is going to be the same steps to begin with as we did with our x single term. So I am going to do 6y minus 7 is greater than or equal to 4y minus 2 times negative 17 halves is minus 17. A lot of the times when I give a problem like this to my students, we think, oh, this is going to be a solving inequalities graphically. No. If I'm telling you to sketch a graph, or I'm telling you to just graph the inequality, you have to use your shading. So this is something we have to keep in our memory log. So I'm going to subtract 4y, this is the variable on both sides. This is the smaller term. And we have 2y minus 7 is greater than or equal to negative 17. Add 7. So my inequality is y is greater than or equal to negative 5. I'm going to plot my point at negative 5 on the y-axis here. And I have to think this is a horizontal line. Y equals negative 5 is a horizontal line. So I'm going to put a solid line through it. And once again, I'm going to use my mathematical reasoning. If it says y is greater than or equal to negative 5, where are my y values greater than negative 5? Down here or up here? Well, that's going to be up top. All these y values are greater than negative 5, so I would shade this whole top section. And when I do that, this is what it looks like. So hopefully after these problems, we are more aware of how to graph our two variable inequalities on a coordinate plane by picking points on either side of the line, plugging them in to see which one works, and shading that side. And also now we're seeing when we have one variable inequality and we have to graph that, how we use our special cases of a horizontal and vertical line, use our mathematical reasoning to choose the side, and that is how we solve these problems.